Let's first understand what dilute and concentrated mean generally. The most important thing about these terms is that they are relative. What do I mean by relative? Here are two beakers on the screen, one on the left and one on the right, and both have 100 milliliters of some colorless solvent. Now in the beaker on the left, I add 20 milliliters of some red solute, and on the right, I add 50 milliliters of the same red solute. In this case, we say that the solution on the right is concentrated and the one on the left is dilute. We are looking at these two relative to each other. And you can see that the concentrated solution is more red in color as compared to the dilute one. This is stronger, we can say. Let me give you another example. We take two empty beakers again, both with 100 milliliters of some solution. The first beaker has 20 milliliters of solute and 80 milliliters of solvent. And the second one has 25 milliliters of solute and 75 milliliters of solvent. Which solution is more concentrated according to you? Yes, it's the second one, because the proportion of solute is more in the second beaker. Now that you know what dilute and concentrated mean, let's move on to understanding what dilute and concentrated acids and bases are. In cases of acids, water is considered to be a solvent and the acid added to the water is the solute. So we have one beaker on the screen here with some water and we add acid to it. As the amount of acid I am adding to the beaker is increasing, the solution is getting more and more concentrated. Now let me ask you an interesting question. When I'm mixing acid and water, should we add water to the acid or should we add acid to the water? To know the answer, what we should know is that the process of dissolving an acid or a base in water is highly exothermic, which means a lot of heat is generated. Now, if we add water to the acid, the heat generated may cause the mixture to splash out, which may cause severe burns. And the glass container which contains the solution may also crack due to excessive heating. You'd probably argue that the same would happen when acid is added to the water, right? Not really, and let me explain why. When we add acid to the water, the reaction will still be exothermic, but the water is a very good absorber of heat. Yes, unlike the acid, the water absorbs the heat. And that is why adding acid to water is better than doing it the other way around. But remember, the acid must be added very slowly, drop by drop, and we should constantly stir the solution. Because if we add a lot of acid directly to water, the heat generated will be so large that even water will not be able to absorb the heat.